Now we're going to turn our attention to some suppressing operators in the Flux class. And if you recall, suppressing operators create a flux or a mono that changes or ignores all or portions of its payload. So we're going to take a look here at 3 suppressing operators: filter, take, and then. Some of these you've seen before in other contexts. In fact, I think you've seen all of these before in other contexts, so we're going to talk about them now. So the filter operator, which is something you should certainly be familiar with from Java streams, will evaluate each source value against a given predicate. And depending on what we see, what the predicate is, if the predicate test succeeds, the value will be emitted. If the predicate test fails, the value will not be emitted. And if it fails, then the value will be ignored and a request is made upstream to get the next item that it could process. Returns, this particular filter operator returns a new flux that contains only the values that pass the predicate test. So you can think of it like a sieve. Although I guess it depends on what you think a sieve is doing. A sieve is letting things through that are small enough to fit through the little holes. So that's kind of what filter is doing as well. Always remember that the number of output elements may be less than the number of input elements when using filter. So you can see here that in this particular example, which we'll look at in more detail when we get to the case study, we're generating a bunch of random big integers, and then we're getting rid of anything there that is even. We're only allowing odd numbers to flow through the filter. So it's kind of like the sieve is selecting only odd numbers to go through, and everything else gets caught in the sieve, if you will. So we'll look at that example in more detail later. This is part of an example that we'll be doing prime number checking. So obviously, if a number's even, there's no point in even bothering to check if it's a prime number because it couldn't possibly be prime. It's obviously divisible by 2 at the very least. Remember that filter can't change the type or the value of the elements it processes, and it may end up, either letting them all through or letting none of them through or something in between, depending on what the values and the predicates evaluate to. RxJava has a filter method that works exactly the same, has the same behavior, and no surprise, there's also a similar operation that's defined in Java streams, and you can see here, same thing, we have a long stream that will only emit odd numbers. The next method we're going to talk about is the take operator, and this takes only the first n values from the flux, assuming that they're n values to take. Obviously, if you have a flux that's empty, take will stop right away. The parameter that's passed is the number of items that are to be emitted from the flux, and it returns a flux that is limited to that many number of elements that it can. As you might expect, because you've seen this before, we use things like take to limit otherwise infinite streams, infinite fluxes. So here's an example where we would normally generate an infinite series of integers periodically in a background thread using interval, which we just talked about. But in this case, we're going to bound that, so we only take S-max iterations of these things. And then there's also a similar operator called take for RxJava as well. These are both these take operations are obviously very similar to the limit operation that you would see with Java streams. This particular example will only emit 100 odd numbers, the first 100 odd numbers, and it uses iterate in conjunction with filter, in conjunction with limit, to be able to stop after we get 100 odd numbers. The third and final suppressing operator we're going to talk about today is then. And what that does is it lets the flux complete, the current flux, and then it'll play the signal back from the provided mono. And the parameter that's passed is a mono to emit from after the existing flux terminates. So it's kind of like the last, it's like the emission of last resort. So basically what happens is any values that normally would have been emitted by the flux, by this flux, the flux that's calling then, are ignored. Any element is ignored. And the completion signal is transformed into an emission of the other mono that's passed in. That's a little weird if you first think about it. It's like, what the heck would we ever do with something like that? Well, and I'll show you an example in a second. It returns a new flux that waits for the source completion and then emits from the supplied mono. So let's take a look at an example of this type of data suppressing operator. And what it's basically doing here is it's just replacing the payload from the flux with another value. So this particular example, which we will, of course, look at in more detail when we get to the case study here in just a minute, this particular example is going to make a bunch of integers using make timed flux sync. We'll look at that when we get to the case study. Then it goes ahead and checks to see whether they're prime numbers or not. And then the very last thing it does is it's going to essentially it's going to display the results and indicate the asynchronous operation completed. So that's what it's doing. And the way it's going to do that is it's first going to call the from runnable method on mono in order to display the string builder that we've been creating to keep track of the diagnostic information we want to log. So it's going to use from runnable to get that printed out on basically on the console. And then it will return essentially a mono to void as the result. So that's just an indication back to the async task barrier that this particular Flux stream is done. And we had the side effect of printing the results using mono.fromRunnable. Now, there are other ways to do this, by the way. There's other means to get a similar effect. We could use the do finally method we looked at before, or the do on complete method that we will talk about later. So there's a couple different ways to do this, but this is one way to do it. RxJava doesn't really have an equivalent to this, although it does have a completable that's used in a similar way. And it's created via, if you use RxJava, there's a thing called ignore elements, and it returns a completable that ignores the success value of this observable and signals on complete or on error. And these are all similar to Java's completable future then run method, which again is a rather obscure method, but can be used in some circumstances in a similar sort of way. In fact, if you take a look at then run, you see it also takes a runnable, just like we did with mono from runnable, which is what we showed over here. So that's the end of some of the other suppressing operators in the Flux class. I think you'll agree that filter is a very useful suppressing operator, plays much the same role, or pretty much identically the same role as what we see with Java streams. And I think you'll also agree that take can be very useful, playing the same role as limit. Then is a little bit more esoteric, but it does come in handy when we're doing things like integrating our tests with the async task barrier, because it's a way to indicate we're done, while still having one final thing emitted before everything shuts down and we indicate to the task barrier that this particular task is finished.